Let us find now a few difficult limits. The first one is the limit of the natural logarithm of the sine of x as x tends to pi from the left. Okay. Keep in mind, when we have continuous functions like the logarithm or the sine, the limit can move inside the function, but keep in mind when they are continuous. Okay, these are continuous functions in their domains. The sine of x is always continuous. The logarithm is the one that it's only good as long as the argument, whatever is inside, is positive. Okay, so here we are saying that x tends to pi from the left. Okay, that means that we are going from 0 to pi. So when that happens, if we look at the trigonometric circle, so we are moving like this, okay? This would be pi. And what are we saying? So the sine of x is going to go to 0, okay? Notice that here the sine is 0 as x tends to pi from the left. Okay, and notice here that we are going from the upper part of the circle. That means that sine of x is positive as x tends to pi from the left. Okay, you can see all this also if you graph the sine of x. Okay, when you graph it, you will notice that that's something like this, and this is your x equal pi. Okay, so you see again that the sine is positive as x tends to pi from the left. Okay, because we are on that in this region. Okay, so what I'm trying to say here is that this means that they are in the logarithm, in the domain of the logarithm. Okay, and then we can just take the limit. Okay, because we have that sine of x, we wrote it here, the sine of x goes to 0, okay, as x tends to pi from the left. So this is going to 0, so the logarithm of 0 is going to be negative infinity. Okay, remember the logarithm looks like this. Okay, this is just for the sake of explanation, it's not the solution properly speaking. Okay, the solution is here. I already said that the sine of x is positive, therefore the logarithm is defined, but the sine of x, even if it's positive, it's becoming 0 as x tends to to pi from the left, sorry. Therefore the limit is negative infinity. And that's it. So this is number 1. Number 2. For number 2, we have here a limit involving the arctangent, which is a fan favorite. Remember, I see this every year in the test, that is written tangent to the -1, and somebody thinks that we are dividing by the tangent. No, that -1 means the inverse of the tangent, and the inverse of the tangent is the arctangent. Okay, remember the arctangent is the angle with tangent 1 over x. And what happens with the arctangent is that things that look very difficult because they involve the arctangent, usually they are very simple. Okay, you just need to write it carefully and you realize that it's a smoke and mirrors. Okay, there is nothing there. So what happens with 1 over x as x tends to 0? You will see what I mean. When x tends to 0 from the right, from the positive, 1 over x goes to infinity. So here we have the arctangent of infinity. And here is when people usually freeze because they think this is not defined, but actually the arctangent of infinity is pi over 2. Why is so? Well, we don't need the circle right now. Notice that the tangent is the sine divided by the cosine, okay? And yeah, actually we needed a circle. And when you move towards towards pi over 2, okay, the sine of x is going towards 1 and the cosine of x is going towards 0, okay? And this is happening from the positive, okay? So when you do 1 over 0, you get infinity. So the tangent tends to infinity. Okay, so that's what we are undoing here. Pi over 2 has an infinite tangent. Okay, so whenever you see arctangent of infinity, that's pi over 2. This is not for this problem, but when you have the arctangent of negative infinity, that's negative pi over 2. Okay, this is just FYI. Okay, so you see what I meant. This was actually not so difficult. And then we have 3 and 4. Number 3 involves the absolute value of a number, okay? And usually people don't like those. But there's no problem, actually, if you just write down what the definition of absolute value is. So 4 minus v in absolute value is 4 minus v if 4 minus v bigger or equal than 0, or minus that if 4 minus v is negative. Okay, so then you can simplify that. You can say, well, this means v bigger than 4. This means v less or equal than 4. Okay, and then notice we are approaching 4 from the right. So we have 0 here, 4 here. We are approaching from this side. V tends to 4 from the right. Okay, so that means that we are, in this case, okay, when v is bigger than 4. So we can write 4 minus v divided by, and then minus 4 minus v is v minus 4. Then I can simplify, right? So this is minus 4 minus v, and I get the limit as v tends to 4 from the right of negative 1, which is negative 1. And that's it. And then the last one was this limit involving the exponentials. This one has a bit of a problem because infinity minus infinity is undefined. Okay, some people would argue infinity minus infinity should be 0. Some people would say it should be infinity. Some people would say it depends. Okay, and it does depend. So what shall we do here? Well, we need to compare, see what is growing faster, if x or x squared. So for that, what we are going to do is factor the x squared and see if that helps, okay? But it does help because now notice what happens here. 1 over x minus 1 tends to -1 as x tends to infinity, and x squared tends to infinity as x tends to infinity. So the product of the two tends to negative infinity. So this is the exponential of negative infinity, but you don't need to write that. The exponential of negative infinity is like 1 divided by the exponential of infinity, which is 0. You don't need to write exponential of negative infinity. You can just say that is 0. Okay, and that's it.